CNY e-hailing company is a company that provides transportation vehicle services. These vehicles can range from low-cost rides such as motorbikes, which can be efficient for example, corporations or restaurants, where they need to find reliable food deliveries, normal car rides, which is the average taxi or grabs, to trucks, which can be useful for transporting cargoes. After the rides, passengers will be able to leave any feedback regarding their experience about the rides, and their feedback on the drivers and the ride and the service will help improve the company and the system. Besides passengers are allowed to make requests, the system also allows drivers to make requests to signal their availability. If let's say they signal their availability and there's a client nearby that found a suitable match that made the request, the system will send a notification to the driver along with the passenger details, including their pickup location, destination, and any additional ride preferences. And simultaneously, the driver's details such as name, vehicle information, and estimated arrival time will also be available to passengers. This is made possible with the collection of previous pickup location and drop location records, allow the system to accurately calculate the total travel time for both the drivers and the clients.
Good day, Miss. My name is Xiao Yan. Now I'm going to introduce about the business rule in our CNY e-hailing system. So the first business rule we set is about driver age. The minimum age requirement for all the drivers on our platform is set to be 21. Means that the driver should be 21 and above. So if the driver is younger than 21 years old, the system will reject the request and then provide an error message for them. We set this business rule is to ensure the safety for our driver and also client. And the second business rule we set is about vehicles. So in our company, we want that each driver to only have one active vehicle. And then after they complete register, they also need to fill in their vehicle details, such as their vehicle model, vehicle color, seating capacity, and also the plate number. So after that, when they work, they also need to display the company logo in their car and also install a GPS device for the platform to track the trips. And the third one is about client. So clients are required to create an account before they use our e-hailing platform. And then when they register, they also need to provide their details such as their full name and their password, email, and much more. And the fourth business rule is about payment. There are quite a number of payment options, for example, like e-wallet, MasterCard, Visa card, cash, and a lot more. So in our business rule, we said that in cash payment method, the payment will be done with the driver himself after the ride, while for e-wallet and credit card payment method, the fare will then be deducted from the passenger's wallet or card after the trip is complete. And then we also said another thing is about the client need to pay before they book another ride. This is because we want to ensure and also preventing both our company and also our driver from the possibility of financial loss. And the fifth is about rating. Clients are encouraged to rate drivers on their behavior, punctuality, and also cleanliness. The rating scale is between 1 to 5, and they also can write some reviews on it. And if the driver continue receive low score like 2 and below, they will be banned and their account may be restricted from our platform. And the sixth is reserve a ride, which is the last business rule we set. So of course, client can reserve a ride through our apps, and then by providing a pick up and also drop off point. Passenger will receive notification once the driver accept request lah. And then a user is prompt to try the request again if a driver is not assigned or if the driver reject the ride. Yeah, I think that's all for our business rule. Thank you.
Hi, good morning. My name is Ng Zangbin. I'm going to show you our ERD diagram. First, this is the overall design of our ERD diagram. There are 8 tables in this diagram, and they are mainly connected with the table rights. I will go to each tables one by one. First of all, there's a many-to-many relationship between the tables of clients with drivers, and they are connected by the table rights, which is a junction table. So without driver and client ID, the rights table cannot be formed. So they are driver ID and client ID are not null for rights. Next, we have the clients and right request table. They are one-to-many relationship. That means one client can ask for more than one right request at a time, but each right request can only ask by a particular client. Then we have drivers to vehicles table, which they are one-to-one relationship. That means each driver can only register one vehicle in our e-hailing system. And this may cause some inefficient for some large company to register more vehicles. I will talk about this later. in the later slides. And now we look at another table, which is driver ride request. This is a table where driver can request for a ride when they are free. They can request to provide the services of transportation. So we have response status and response time in driver ride request also. It is a one-to-many relationship between drivers with driver ride requests. Then we have ratings table. It is connected to rides table with one-to-one relationship. That means each rides can only have one rating. Also for payments table, it connect one-to-ones to rights table also. I'm talking about the constraints here. I will just mention some of the example of the constraint, such as payment amount must be greater than 0. And how we make that is by take a look at the fourth line of the code for the first picture. You say that check payment amount more than 0. So this can helps to constrain the payment amount must be greater than 0.
Besides that, we have also inserted data into our CNY e-hailing database. So first of all, we create tables for drivers, vehicles, driver ride request, ride, client, rider request, rating, and also payments. So each of the table, definitely we include the attribute and the data type and the constraint like primary key, foreign key, and a lot more. This is a client table, the ride table, ride request, vehicles, driver ride request, payments, and also rating. So I have inserted 15 drivers for drivers table. As you can see, here we got the driver ID, their name, age, email, and much more. So each of the age is 21 and above, as we have said. And then their email, their Gmail, their email is unique, phone number unique, their license unique, yeah, and the time they participate in. And for clients, same. I also have inserted 15 clients. And for vehicles, as our business rule said, each driver can only have one vehicle. So we have 15 drivers. Definitely, we're going to have 15 vehicles. And for the driver ride request, I have inserted, I think, a lot. Yeah, I have inserted 50 values inside. And for driver, they can accept and also reject the ride. Same goes for the client. They can also accept and reject the ride. So if both of them, if both the ride, the driver and client accept the ride, so they will be record inside the right table. So yeah, so both of them, if both of them accept, they will be inside the right table. And for the rating, the client are encouraged to rating, but they cannot do so. Yeah, so 20 of them have rate our driver. Yep. And for payment, definitely we refer back to the right table. There's 30 right, so definitely with 30 payment. Yeah, I guess that's all. Thank you.
Hi, my name is Xian Kang. So now I'm gonna run the queries from part 2 of the assignment. But before that, I'm just gonna show all the tables that exist. So this is the driver table. This is the vehicles. This is the driver request. This is our rights table. And this is the clients table. This is the rider request. This is the ratings. And then this is the payments. So the first query is a query that requires an outer join. I'm going to display the client name and make the payments between 20 ringgit and 40 ringgit, and display the payment and to display the driver name that received the payment. So I need the client name, I need the driver name, and I need the payment amount. I'm going to start from currency. I'm going to right join to the rights R on the client ID as the foreign key and the primary key, and then I'm going to left join the driver's D and right join payments P. And this is the condition where the payment amount has to be more than or equal to 20 and less than or equal to 40. Run the query. This is the client name, the driver name, and this is the payment amount, just between 20 and 40. The second query is a minimum of 4 table joins to the group by function. So I'm going to display the ride request that have been accepted with the driver that drove Toyota Vios and count how many times each client has ridden it. Display the client ID that made the request, driver ID responded, the amount of times the client has ridden a Toyota Vios in the descending order. So I need the client ID that made the request, I need the driver ID, I need the count how many times the client ID is in the rights as the amount of time the client has read to the Vios. I'm going to start from the rider request table, and this is the first join. So this is the first join, and then this is the second join, this is the third join, and this is the fourth join, and this is the Toyota Vios as the instruction said, and then this is the group by function, and this is ordered by descending order. I'm going to run this query. It returns me to table, and this is the amount of times the client has write Toyota Vios in descending order, which is from biggest to smallest. The third query is a string parent matching and the date function query. I need to display all vehicles that were driven by drivers with M in their name, and pick up time is in December 2024. Display the vehicle's model, the driver name, and the pickup time of the ride. So I'm gonna need to display the driver name. I need to display the vehicle model and the pickup time on the right. So this is a string matching with M in their name. And then I need a date function. Query is to char. I'm gonna convert it to char and check if it's in the date within of December. So when I run the query, this is the table I get. It's in December, and this is the driver name with M's in their name. The fourth query is a query having both OR and AND. So I'm going to display the rights that have the rating of 1 star or 5 star and have the payment more than 50 ringgit. I'm going to display the right ID, the client ID, the rating, the payment amount, and also the driver ID over here. And this is the condition where the rating is 1 or 5. I'm going to check this first, and then and the payment amount is more than or equals to 50. So I'm going to run this. So here's the payment amount, that more than 50. This is the rating, 1 and 5. This is the client ID, the driver ID, and the right ID. The fifth query is a query that consists at least 2 subqueries. So I'm going to display all drivers that have the ratings of 4 stars and above. I'm going to display the driver ID and driver name. Oops. So here I'm going to select driver D, where driver D this is the first subquery. And then I'm going to select the right in the second subquery where the rating 4 stars and above. I'm going to run this. This is the driver ID and the driver name that has a rating of 4 stars and above. And this is the case scenario of e-hailing. I'm going to provide a list of drivers who have completed the most trips within the last month and have a rating of 4.5 stars or higher. So I'm going to select the driver name, the count, the total trips, and the average rating from driver's D. Here's how I'm going to join it. And then this is the pickup time, where this is the start of last month, which is November. And then this is the start of current month. So this is the range within the last month. I need like a group by function because I'm using count. And I'm going to order it by descending because this is the list of drivers who completed the most trips. And if I were to run this query, I'm going to get the driver ID here, and the driver name, and the total trips, which is 2, 2, and 1. And this is the average rating with 4.5 stars higher.
Now we'll talk about the anomalies. First is update anomalies. As you can see, they are pickup location and drop-off location in both writes and write request tables. Now, we can enhance this by only inserting the pickup location and drop-off location in write request, and then we can add a write request ID in writes table. This can reduce the redundancy and reduce these update anomalies. Second anomaly is insert anomalies. In the first table, as you can see, the client ID acts as a foreign key, which is not now. This will cause the clients cannot request a ride if he or she did not fill up his or her data. And the second table, which is inserting a new vehicle into the vehicles table without adding the driver ID, is prohibited. So this will cause insert anomalies also because the driver ID in the vehicle tables is not now. Now we come to deletion anomalies. When a match rights is cancelled by the client for some reasons, the rating or payments table are being affected because the right ID is not now in these both tables. The payment and ratings thereby are not recorded in this case. There might be circumstances where the client is angry about the ride experience and wants to cancel it halfway, and the payments and rating thereby are not recorded in this case. This will cause a lot of conflict about the payment, and the data analyst could not figure out what was happening according to the review comment of the rating table. And there are other constraints also. Next, I will introduce the specific improvement to our ERD diagram. First improvement is the payment table currently assumes the payment is associated with a ride only. But in reality, there is a possibility where the payment is splitting or adding other costs. Also, it might be refunded for some reason, like cancellation by the driver because of the traffic. So how we can fix this is by inserting a new attribute called payment status and transaction reference. Payment status, which could be like ongoing or refunded or pending and so on. And another attribute can be inserted, can be like another attribute, transaction reference, is helping for a better tracking and analyzing the payment in the future. Also, we can set the status of right ID in the payments table as remove the status of not now, so that the payments record will be recorded in any case. The second improvement to our ERD diagram is changing the relationship between drivers table with vehicles tables from one-to-one to one-to-many relationship. This allows the driver to register more than one vehicle under his or her identity. This function is only accessible for a registered legit company to prevent fraud and scamming.